Hello, this is Barrett from Cypress College, and in this video today, we're going to cover the AWS Academy Cloud Foundations Lab, building your own VPC and launching a web server. So essentially, VPC stands for Virtual Private Cloud. This is kind of, you can think of it as your own little piece of the AWS cloud pie. You can create multiple VPCs. They are specific to a certain region that you are that you've selected. So I believe in this lab we're going to be doing the North Virginia region and US East 1. We'll double check that in a second. But then on top of that, and if I scroll down, this diagram is very useful. On top of that, we're going to first use the VPC wizard. That's going to create both a public and a private subnet within that VPC. So you can see here, this is the region that we'll be in. We will create a VPC, that green box there. Within that VPC and through the VPC wizard, we're going to create a public subnet, a private subnet, and you will see that also generated is an internet gateway. This allows our public subnet to communicate to the internet and allows outside sources in to our public subnet. And then we'll also create a NAT gateway, or network address translation. And this is what's important for private subnets to be able to send out to the internet. So think of a database server. It's always best practice to have that sitting in a private subnet, but eventually other services are going to make requests to that, and that information is going to have to be sent out. So that happens through a NAT gateway. And of course, you wouldn't want an internet gateway connected to your private subnet because then it would no longer be private. Other outside sources would be able to connect to that private subnet, or like I said, it would then become a public subnet. So, sorry, I don't want to get too deep in the weeds because that's what the lab will do as we walk through it. And just another overview, we're going to create a VPC, we're going to create subnets. We'll also configure a security group, which is super important in ensuring that only you're enabling the least privilege, a principle of least privilege on any of your services, like an EC2, for example. And you're going to see how we're going to create a security group, only allow HTTP port 80 traffic to come in to make those web requests. And then finally, we will launch an EC2 instance. We're going to run a script on that to auto install a web server. It's going to install a MySQL database, for example. And that's pretty much it. So if you're doing this as well in your AWS Academy environment, you will have access to this walkthrough. I'm going to go ahead and pull this over. That way we can just focus in on the AWS Management Console, and we'll go ahead and get started here. So similar to like I showed you with the Identity and Access Management Lab, there's multiple ways to access the different AWS services. So if you've recently visited a particular service, it will show up right here. So we could potentially access VPC right here. We could also come to services. We could locate it within here under networking and content delivery under VPC. I generally don't default to this because sometimes you're staring at so many services here. Sometimes it can be kind of hard to find. And then the most easiest way I've found is you could just search for the service you want, and then we can go to VPC from here. All right, so now the next step, as I said in the beginning, we are going to launch this via the VPC wizard. So this makes it very simple. We may get into other walkthroughs where we're doing this more manually, create the VPC, then create the subnets, create the internet gateway, create the NAT gateway, for example. But in this case, we're just going to click on Launch VPC Wizard. And this is very handy, and I'd recommend that you check out each of these four options, and we'll do it right now. So here we could set, okay, well, I want to create a VPC with only a single public subnet. So this obviously wouldn't even create an internet gateway. It would just or I'm sorry, it wouldn't create a NAT gateway. It would only create an internet gateway because we're only creating a public subnet. Now, the one that we're going to use for this lab, we're going to create both a public and private. You can see that here is our entire VPC. We'll have a public subnet. The NAT gateway will reside in there, and a private subnet, and this NAT gateway allows traffic outside of the private subnet to be sent through the public. And there are two other options here. We could do public and private subnets with VPN access. So if you have your own on-premise server, on-premise environment, that can VPN into your private subnet. And same thing here. It's just only provisioning up only the private subnet and still that same VPN access. But we're going to go ahead and select this second one here. And you can see that it creates a /16 network with two /24 subnets. And we'll talk a little bit more. We'll get into the networking here in the next section. Okay. So this is our VPC CIDR block. And if you're familiar with networking and subnetting, this may all make sense. But if you're new to it, that's okay. You don't really need to know a whole lot of details, but I will explain what some of this means. So when you see this /16, well, actually, let me back up. An IP address is 32 bits in binary. And you see the dots here, and what this does is it breaks this up into 4 octets. So you have the first octet, the second octet, third octet, fourth. Now, this /16 means that the first 16 bits are reserved for the network. And each of these octets are 8 bits. So remember I said IP address is 32-bit binary. So these first 2 octets make up the first 16 bits that are fixed for the network. So what that means is subnetting can begin here with this third octet. And you're going to see that you could already see right here, we have a public subnet being built in a private subnet, and the increment is happening in the third octet. So each number increment will eventually get to creating a subnet in .2.0. We'll create another one in .3.0. And these are going to be our different subnets. So that's essentially what this means here. Because the first 16 bits here are fixed, that makes these, dragging things around, there we go. That makes these 2 octets, the third and fourth octet, flexible. And that's what allows us to start assigning numbers to that third octet down here. Now, before we move down to the subnets, we just have to give this VPC a name. And we'll call this lab VPC. Okay, so that defines the overall VPC CIDR block. Now we move into our subnets. And this is where we're gonna have a /24 CIDR block for our subnets. Now remember, what this means is the first 24 bits of this IP address are fixed, and that's going to be here. So what that means is within this subnet, we now have 256 IP addresses available. But as you notice, it says 251. Now, the reason for this is that AWS reserves 5 IP addresses per subnet. And this is for the network address, the network broadcast address, which is very standard in subnetting. They also reserve for the local router that they use on premises. They save one for DNS resolution, and then there's one that they just save just for a rainy day for future use. So that's also, keep in mind, that's probably a very common AWS CCP certification exam question. For example, how many IPs does AWS reserve per subnet. Okay, so that's why technically this is 256, but we only have 251 available. And same up here too. You see 65,531. The way that you get this is that, okay, we have 16 bits fixed. We take 2 to the power of 16, and that's actually 65,536 minus 5. You get this number here. So, and then here, because we have 8 bits flexible, up here we had 16 bits flexible. Here we have 8 bits flexible. So it's actually 2 to the power of 8, which is 256, but minus 5, we have 251 available. So hope this isn't getting too deep in the networking weeds, but I figured if you don't have that kind of introductory network experience, this would be useful so you can understand what the heck these CIDR blocks are. So with that out of the way, and so now we're going to go ahead and select the availability zone. So as you can see here, we have 6 different availability zones listed. So I'm going to go ahead and select US East 1A. And remember, we are in the North Virginia region. This is US East-1 region. And so you could say that US East-1 has 6 availability zones. These are 6 different physical data centers that are available within the kind of northeastern region, right? And then we're going to also place the private subnet also in this same availability zone. So we currently have 2 different subnets in the same availability zone. Now we want to go ahead and signify an elastic IP address to the NAT gateway. So remember, refresh the NAT gateway is what is going to allow anything within the private subnet to reach out to the internet. Okay, and then that's all we need to do here. I know it was kind of long-winded explaining all of the CIDR blocks and subnetting, but here we're ready to keep going on the lab. Now this is going to take a moment. I think, once you get to the NAT gateway status, it will take a few minutes. So I'm going to go ahead and pause the video and come back to it. All right, so the VPC wizard has completed. We see VPC successfully created. So we can go and click on your VPCs over here in the left corner, and you could see the lab VPC that we just created. Now there is appears to be another work VPC, and this is going to be what's called a default VPC. So anytime you create a new account in AWS, there's going to be default VPCs in pretty much every region. And I can actually show this by, if we change our region to US East 2, for example, you see the lab VPC is no longer there, no more work VPC. That's because we are in an entirely different region of our account. But you could see that this is just another default VPC. Same if I move to US West 1. Completely different default VPC here. So let's go ahead and switch back to US East 1, the region that we're working in. And we're back to our lab VPC. So what we're going to do here, we've used the VPC wizard to create the VPC itself, a public and a private subnet, a NAT gateway, an internet gateway. But now we can go ahead and create 2 more subnets ourselves. So if you click on the left side under subnets, you see a lot of different subnets here. A lot of these, you can notice that they're a part of that default VPC. One of them is a part of that work VPC. But here, the private subnet and the public subnet, these are the ones that we created. And if I bring that, there we go, you see lab VPC here. Now you can click on these fields up here to sort by name. Maybe if we sort by the the IPv4 CIDR block that will organize it a little bit better for us. And if you see this and notice, hey, how come these are both the same? Remember that these are two entirely different VPCs, right? So this is the work VPC and this is the lab VPC. All right, so let's go ahead and create two new subnets. So first thing we want to do is choose our lab VPC. We're going to give this a subnet name of public subnet 2. Now for availability zone, let's go ahead and select 1B. So essentially what this is doing, this is giving us a high availability architecture. We can develop systems that potentially exist in both availability zones or AZs, as they're often referred to, so that if one goes down, there is still a backup, right? And you can take it one step further and say, I really want really assurance that my systems will not go down. So I'm going to enable cross-region, and I'm going to spin up an EC2 instance in US West 1. So there's one on the East Coast, and then there's one on the West Coast in case something really catastrophic happened in a specific region, and then you have that backup. So that would be more fault tolerance and maybe used in a disaster recovery scenario. But anyways, for here, we're going to continue our subnetting. And so remember, we left off at the 10.0.1.0. So we're going to move to 10.0.2.0/24. We'll keep this tagging is very important. So this has already been kind of populated for us. The name is public subnet 2, and we'll go ahead and create subnet. And you see that here, you may be wondering, where are the rest of my subnets? You can notice here that it's just being filtered automatically. So we can X that out, and now we see all of our subnets. So let's go ahead and create one more. And we're going to create the private subnet. So we'll do lab VPC again. We'll call this private subnet 2. Let's put that in the same availability zone, 1B. And we're going to increment by 1 here. We'll do 10.0.3.0/24. The name is private subnet 2, and we'll go ahead and create. And if we X out the filter, we now see we have public subnet 1 and 2. And in fact, you know what? I'm going to rename this just so that you can click on the edit name here. I'm just going to add public subnet and private subnet 1. There we go. And you notice the IPv4 subnet 10.0.0.0, 1.0, 2.0, 3.0 for each of the different subnets. So next up, we could take a look at the route tables. And probably best to expand this VPC field here. So we're going to be looking at both of the lab VPC route tables. So the first one we want to look at is the one that has main set to yes. So we're going to click this. And if we go to routes, you're going to notice that when you see quad zeros followed by a /0 CIDR block, this essentially means internet. Just think internet. It just imagine coming from the internet or potentially going to the internet. That's the destination. So now you could see that this is linked to the NAT gateway. And another thing to remember, the NAT gateway, you always want to associate that with the private subnet. So in this case, this is the private route table. So we can also rename this to make it a little bit more clear. And we could call this private route table. And now next, we want to associate those two private subnets with this route table. So right here, we'll click Subnet Associations, Edit Subnet Associations, and here we want to select Private Subnet 1, Private Subnet 2, Save Associations. And now if we go click on that, you see 2 subnets are associated. We go back to here, we see them listed under these subnet associations. And so now we're going to go ahead and do the same thing with the other lab VPC route table, and the one that main is set to no. And if we look at the routes here, we see that that destination to the internet is targeting the internet gateway, the IGW. And remember, we talked about earlier, if it's related to the internet gateway, that is connected to any public subnets. So we could call this the public route table. And now next, we want to do our subnet associations. We can see that it's already associated with that first public subnet because remember, we used the wizard and automatically created and connected the internet gateway. But if we edit, we could also add that second public subnet. And that has been added. We see 2 here, subnet associations here. All right, great. So that is the core of setting up a VPC kind of baseline network infrastructure, right? So we created the VPC. We've created both public and private subnets in 2 different availability zones. So we have that high availability option to deploy potential services in these areas. So next up, we're going to move into creating a VPC security group. And you will see in the left-hand side here under security, we have security groups. And essentially, this is what we will end up attaching to our newly created EC2 instance, which will house the web server. And this security group is what's going to allow inbound HTTP traffic on port 80. So if we create security group, we want to give it a name. We'll call this web security group. And it's always important to be very descriptive on these security groups because you have to imagine in a workplace scenario, you're working with other IT staff, other security team. It may not always be only you managing this and working with these services. So you want them to be able to know very quickly what these security groups are used for. So under description, we'll say enable HTTP access, and we need to assign this to our lab VPC. So that way, this security group will be available within this VPC for any services like EC2 that we are provisioning. And we'll go ahead and add a role. You can see here we have a lot of different options for various services based on port range and based on the source. Where are these requests coming from, right? So for this lab, we're going to add HTTP, and you can see it autofills to port 80. Now, I do want to mention this is not best security practice, because HTTP is plain text. We generally want to use HTTPS, which you notice when I select that, it changes the port range to 443. So this is HTTP secure. The S is for secure. It's using TLS encryption. But for the sake of the lab, I know they're just wanting to keep it simple. The web server installation script is very, very plain and simple, and it's only running on HTTP port 80. So that's why we'll leave it at that for this lab. But I wanted to make sure as you're learning even just the basics of this, that you understand these core security concerns in that we always want to use HTTPS. Okay, so now for source, we want this is theoretically a web server. We want people to be able to connect to it. So we'll want to select quad zeros. Remember, this basically just means the internet. So anybody externally on the internet will be able to connect via port 80 to send HTTP requests. And description here, we can add permit web requests. And then finally, you have the outbound rules, which this is technically this is for the web server to send out, right? So here, as you can imagine, we would need it can send anywhere. And tags, we'll leave this off for now. All right, so let's go ahead and create that security group. That is created. You see the inbound rule down here, HTTP port 80, allowing from anywhere on the internet. So now our last step here is to create that EC2 web server. So we can go up to the search for EC2. Let's move over there. And you could launch an instance straight away right from here. You could always go into instances and check out what's happening there. Oh, you know what it actually looks like? It's showing some terminated from another time that I ran this lab recently. So just ignore those. Normally you would just see the Bastion host here, which will be normal when you run this for the first time. Ignore the Bastion host. We're not using it. Essentially what a Bastion host is used for is for management to connect through a public subnet to potentially reach things that are within private subnets in your AWS account. Now, I will say that AWS has since added new features and new ways to connect to private subnets without the use of a Bastion host. So that's something we'll talk about later in the course, because that will save you. Because as you can see, this is publicly exposed. So it's best practice to try to limit the amount of boxes that are publicly available, right? You want as much as possible to be walled off behind private subnets, and potentially going through things like load balancers and NAT gateways. And that should be the only thing in a public subnet. But like I said, these introductory labs are pretty simple, and we'll get into all those fine details later on. So anyways, we just want to launch instance up here in the top right. So first thing, we need to choose an AMI, an Amazon Machine Image. So we have lots of options, lots of different Linux distributions, Ubuntu servers. There are Windows servers down here. But essentially in these labs, we're going to be looking for things that are free tier eligible. And in this case, we want to launch an Apache web server. So we will need to use the Amazon Linux 2 AMI. So we'll select that. And here, choosing an instance type, we're going to go into more details in an upcoming EC2 lab. But essentially what you're seeing here is the different types, how many CPUs it has, how much memory it has. The majority are going to be EBS only, and network performance. So it all depends on the type of network speed you need, the type of CPU performance, the type of memory. Because if you scroll down, you could see there are some quite powerful EC2 instance types here. But of course, they're going to cost you. So, but for this case, we're going to stick with the free tier eligible. I don't even think it'll allow you to do anything else, but we'll use a T2 micro, choose next. And now here we'll need to determine our network subnet and assign an IP. So first things first, select your lab VPC. Let's go ahead and put this in the private subnet 2. And this is important Or no, I'm sorry. I'm in such habit of placing these in private subnets, but in this lab, we're actually going to put it in public subnet too. And then here, auto assign public IP, we're going to set this to enable. So it's disabled by default, which is good because you don't want to accidentally put something in a public subnet that you didn't mean to, and then all of a sudden it has a public IP, and then all of a sudden people are scanning networks and seeing that out in the open and they're able to access it, right? But in this case, we do want to enable this. We do want to make this public so that we can actually verify that this works. So, like I said, this is mainly just because it's a simple introductory lab. In the future, we'll talk about load balancers and how you can. That's what you make public, and you make requests through a load balancer, and then that gets sent to an EC2 that sits in a private subnet. Okay, so we don't have to change anything else in this area, but very important down below, we want to look at advanced details. And this is where under user data, you can kind of think of this as user scripts. So you can even see here, it says you could specify user data to configure an instance or run a configuration script during launch. So I'm going to go ahead and actually just bring this over because this is a good view of the script that I'm going to actually copy to my clipboard. So essentially what this is going to do, once the EC2 instance loads up, that the AMI is loaded, it's going to run this script. Basically, it's saying this is a bash script. The Linux distribution is CentOS. It runs the bash shell, stands for born again shell. So, and then also anytime you see a hashtag in front of one of these lines, that's just a comment, and it's just a description of what's about to happen in the script. So install Apache Web Server in PHP. It's running the command yum install. Yum is the package management command for CentOS distributions. It's installing the web server, MySQL server, and PHP. The -y is super important because oftentimes when you install major services, it might eventually prompt you for do you want to do such and such a thing? Do you want to continue? And you'll say yes or no. Because this is meant to be automatic and run as a script, we want to make sure we're forcing those yeses. If we didn't include that, it likely would not complete. And then the server wouldn't be automatically provisioned and all that stuff. So now next up, we have download lab files. So literally this wget command is just grabbing the zip file, and then we're unzipping it and placing it in this directory, which is where the web server looks for to know which website, which web application to serve up when the request hits, right? So, and then finally, we just have to turn on the web server, which are these commands right here. So I hope that was a good overview to help you understand, what this script is doing, why we do it, because imagine in an enterprise company and you are very often provisioning servers, you create images based on that, and you have these scripts that just automatically install everything that you need, start any services that need to be started, install any agents for any type of malware detection software that your company runs. So that is why this is so useful. So remember, just make sure to copy this to your clipboard, and we're just going to paste that right into user data. And as long as you just copy and paste it, the format should be fine. You got to be careful because one little format error, if there's a space in between that, it's not going to install it properly. So my best advice is if you have an issue loading the web server, you might have had an issue with copy and pasting the user data script. But once that's in there, we can go to next, add storage. We can leave this as it is, a standard 8 gigabytes EBS volume. We'll go to next, add tags. This is always very important. We always want to have proper tags. So we'll name this web server 1. Once again, this is useful for your coworkers to know what you've done, to understand what this box is. And then we'll go to configure security group. So I have some things to say here. First, I just want to point out, as a security best practice, sometimes when people create these new EC2 instances, they might be a bit lazy and they don't think ahead. They don't create a security group specifically for it. And something that's really interesting is the launch wizard one. Now, if I just was in a hurry and I was like, yeah, I just want to launch this thing, it would have created a role that allows SSH port 22 traffic from all sources from the internet, right? And I will say this, in a lot of cases, you do need to be able to remotely connect through SSH, through port 22 to administer the machine, but you should always specify the IP addresses specifically to where it's coming from. So let's say, for example, actually, I could use our our private subnet. Let's say this was in our private subnet and I wanted to be able to come from anywhere from this subnet within the private network, right? So as long as I was connected maybe to the internal network through VPN, for example, then I would have SSH access and nobody else would. Or if I'm coming in from home and I'm just I'm throwing out a really just a random IP, and this is even an example of a private IP, not public, but you get the idea. Let's say that this is my IP address of my home PC, and the /32, this is something really important to understand. If you want to specify, I only want to allow SSH access from this one machine, you signify a /32 CIDR block. And if you think about it, this means that, remember, we talked about earlier, an IP address is 32 bits. And this means that all 32 bits are fixed, meaning that no other address besides this address can be used. Okay. So I digress. Like I said, this is not a part of the lab, but it's so important. And we are going to talk about it more as the class goes on. But it's so important to understand at the fundamental level that I just had to bring it up. But so in our case, we were thoughtful. Remember, we created a security group already. So I'm going to choose select an existing security group. And we have this web security group. Description is there. We know what it's meant for. And if we check it here, we see that role again. We're only allowing port 80 from all sources for this web server. So that makes sense. No SSH from anywhere, right? Now, I will say we would technically need to include SSH in here for potential remote administration, but we don't need to worry about that for this lab. So I'm going to review and launch. And here it actually warns you. It says, hey, you're not going to be able to connect to this if you don't make port 22 open, but that's okay. We're going to go ahead and continue. And this gives you a review of the instance launch. We're going to go ahead and launch. And now this is another kind of important thing. We're going to talk about it more when we focus more on EC2 specifically. But essentially, this is where you would either create a key pair, which is what you need to connect to this instance remotely. You would download a private key file, or you may already have had a key pair that you've used for another box. You can use the same one, right? So you could use it for multiple Linux instances, for example. In this case, we're going to skip by this because, like I said, we are going to come back to it. I'm going to say proceed without a key pair. And I'm just going to acknowledge that without a key pair, I can't connect to this through, remote access. So now let's launch instance. All right, your instances are now launching, and we can click on View Instances down here. And so once again, sorry about the mess. The terminated ones, those were from a previous lab session. But you see this pending. This is the web server that we just launched. So it'll take maybe 30 seconds. But if you look at the details down here, you have the public IP address, the private IP address, the public DNS address. If you click on security, this is where you can see which security groups are attached. So you can attach multiple security groups to EC2 instances, for example. And it looks like it's running. So now we can just copy the IP address and open a new tab. Oh, and you know what? It's actually still initializing. Let's hold off on that for just a second. You can always hit refresh here. Okay, so it's still initializing. Sorry about that. Also down here, while that's running, you can go to the networking tab. You can see which VPC it resides in, which subnet. So remember, this is in the public subnet 2. You could check out the storage, check out status checks here. You see we are still initializing, right? Okay, I'm just going to give that a second to complete. All right, and there we go. We have our status check, 2 of 2 checks passed. It's running. So now, once again, let's just go ahead and select the IP address. Actually, nope, I already have it in the tab. And then when we go ahead and visit that, it's a very, very basic web app, but you can see here, we could probably verify the instance ID. It's I0A895, and we could see that matches here. So this is essentially just showing the current CPU load of this EC2 instance, but we are connecting to it through the public subnet. This is literally running in AWS right now. And it's interesting, you noticed how there's this red bar here. It says connection is not secure. Remember what we were talking about, we're running on HTTP and not HTTPS. So HTTP port 80 is clear text, it's unencrypted, whereas HTTPS port 443 is encrypted and not clear text. So that concludes this lab. I know I got into a lot of details about some things, but some of those fundamentals are really important to understand if you don't have that previous experience. So hopefully that added some good context and you have a better understanding of all of these networking concepts. So, all right. Well, thanks a lot for joining, and I will catch you in the next one.